find the rate of the reaction in terms of reactants or products. Which of the following is used to find the rate of reaction below in terms of change in concentration of C, delta C? And he given us a lot of answers, but we will not look at the answers here. I have some doubt about the answer. So let's see what's our method here. We need to find the rate of the reaction, and the rate of the reaction has to always be a positive value. So if he has given you the rate of reaction in terms of change in concentration of one of the reactants, like here we have A, we are always going to say that it's equal to the change in the concentration of this reactant. So if it is in terms of A, so it will be change in the concentration of A per time. So change in time. So if it's change per one of the reactants, or P, for example, it will be change in its concentration. This is the rate of the consumption of this reactant per time. And in order to make this value positive, you have to negate this value. Why? Because let's imagine that this is a reactant A. At the beginning of the reaction at time 0, it's equal to 100 molar or mole per decimeter cube or per liter. And after 50 seconds, let's say time is equal to 50, it becomes 50 mole per liter. So to find the difference, which is the change in the concentration of A, you will have to subtract the 50 minus 100. This is going to give you a minus 50 value. And if this happened in 1 second, so dividing to find the rate per A, you will have to divide this negative 50 per 1 second. So it will be, your rate is equal to the rate of the consumption of A is negative 50 molar or mole per liter per second. I will talk about the units now. So you can't give this value of rate as negative. It has always to be negated. That's why it has to always become positive. So we have to put a negative here. So when we put negative of this value, we'll have to get a positive result as the answer. So it's equal to negative. So it will be equal to plus 50 moles per liter. We'll do this also with the other reactant P if he asked us about. The most important thing here is to watch out for the concentration coefficient. So there is a 3 here. If he's saying 3A here, then you have to put 1 over 3 to get the value, because this reaction rate depends on your reactant coefficient. It is as fast as 3 moles of the A. You have to divide this by 3 to get the rate per 1 mole. So you have to get the rate for 1 mole only. You have to find it divided by 3. So divide this value by 3. So we'll say negative 50 or 50 over second divided by 3. So when you divide this value by 3, you will get your correct rate. So it's equal to positive 50 over 3 moles per liter. So what you have to do is to make 1 over the number of moles. So 1 over the number of moles, which is 3. And here it will be negative also, 1 over the number of moles. What is the number of moles of B? That's 2B. And then that's 4C. So we'll make it 2. If you want to make the rate of the reaction per mole of the products, which is the concentration of change in the concentration of C per unit time, this time you will not negate it. You will not make it negative because it's already a production. So it's increased in the concentration. So it will become positive by itself. No need to make it negative. So we'll make negative here. No, it will be positive 1 over the number of moles are 4. So 1 over 4. So for this answer, this is the right answer, plus 1 over 4 change in concentration of C per time. This is actually the meaning of the rate of the reaction. It is the rate of consumption of the reactants, how fast the reactants are being consumed, or the rate of production of products, how fast the products are formed. As the reaction happens, as the time passes, the products increase and the reactants decrease. So The rate of the reaction will tell us if the consumption is fast or the production is fast. As a general rule, if you have a certain equation in which, let's say, you have reactant A reacts with reactant B to form reactant C and reactant D, and the number of moles is called like that. This is, let's say, it's alpha moles and beta moles of B and delta moles of C and gamma moles of D. So the rate is equal to negative, because this is reactant, 1 over alpha, which is the number of moles of A, where there is a change in the concentration of A divided the change of time. If you are talking also about B, then it will be the same thing, also negative, and should be 1 over beta again. While if you are talking about the products, it will be concentration of C or D, and every one of them will be positive in this case because you don't need to negate it. And this is 1 over the number of moles of C, which is D or delta here, and D is gamma. What about this reaction which speaks about the rate law? What is the rate law? The rate law is a certain equation which gives you the rate of the reaction. It will tell you that this is the rate of reaction. It's equal to K. And what is K? This is a fixed number. This is a constant number called the rate constant. And then you will multiply this one by certain values related to the concentration of A, B, or whatever reactant you have there. This equation is going to give you information about how the rate of the reaction is affected by the change in the concentration of the reactants. So how the rate of reaction will be affected by changing the concentration of the reactants. Does the change of the concentration of the reactants make any effect on the rate, or it doesn't? And how is the effect? Numerically or mathematically, you will try to find this out. How you can find this equation? How can you find this equation? The only way to find this equation or to calculate it is experimentally. So there is no way that you know how to write this equation without practically doing this equation. So it's not related to anything. You cannot find it from the number of moles. You cannot find it by anything except when you do the experiment, and we'll see this in the next question. The relationship between the rate of the reaction and the concentration of any of the reactants is known as the order of the reaction. It's called the order of reaction in relation to certain reactants. So if I say that this reaction is first order with respect to NO2, so what is my reaction? My reaction is the reaction between nitrogen dioxide and fluorine to form N2NO2F. So if it's like that, this is my equation. The rate law, or this special equation that I'm gonna write, will tell me, is there any effect of changing the concentration of NO2 on the rate of the reaction? Is there any effect of changing the rate of the reaction due to the change of concentration of F2? That's what we will show in this equation. But how do I know the orders? We said that we know the order experimentally. So let's see, what did he say? He said that the reaction is first order with respect to NO2. What does it mean it's first order? It means it's affected by changing, the rate is affected by changing the concentration of A in the order of 1. So we'll write here 1. And what is A here that he mentioned? He specified it is NO2. So in our example here, the first reactant is called NO2, and the order that he mentioned is 1. So again, reaction, it's first order with respect to NO2, and first order with respect to F2. So I will write here F21 and NO21. This is my rate law equation. This is my rate law equation in my example here, to the power of 1 to the power of 1. You have to take care of two things. The first thing, you cannot find these numbers or these orders, we call it the order of the reaction in respect to the certain this reactant and this reactant. You can't find them except experimentally. You cannot find them except experimentally. The second very important thing, that it is these numbers or these orders are not related at all to the coefficient. They are not related to the coefficient. And the proof of that is that you see the coefficient of NO2 here is 2, but we have chosen the number here for NO2 to be 1. According to what did he say? He said it's first order. So he will always give us the order, or we can find it out like we see in the next question. Here is also first order, 1, and by chance this number is 1 here. So it's not necessary here. The proof is that it's 2 here and 1 here. So is this correct? Yes, this is the correct one. R is equal to K NO2 1 and F2 1. How do you know this is correct? This is first order and this is first order. So what about the other options? Why the other options are not correct? Let's see. If this answer was right, he should have said like that. The reaction is second order in respect to, the reaction is second order in respect to this first reactant. And what is the first reactant? What is the first reactant? The first reactant is NO2. So if he said it is second order with respect to NO2, then this number will be correct. But he said first, so it's not correct. And this one will be first order with respect to F2, so that's correct. So the only mistake is here, this is 2, not 1. When this is going to be correct, so that's wrong, of course. So this is only right one. What is wrong here? He said first order NO2, so that's fine. But first order to F2, and he said 2. We will understand what's the meaning by these numbers 1 and 2 now when we talk about the order again experimentally and how did we find it out. Then when this will be, so this is wrong also. When this will be right, it will be right if he said it is second order in respect of NO2 and second order in respect to F2. Just bear with me a little bit and stay with me. You will understand what is the meaning of first order and second order in the next questions. What is this? This is totally wrong, fabricated. This is not correct. Now, this is a very good chance to know the relationship between the concentrations of the reactions change and the rate of the reaction, and how we can use this one to write the rate law of the reaction. This equation here we have is x plus 2y give us 3z. I want to know what is the effect of changing the concentration of x on the rate of the reaction. Does it have any effect? It has no effect, or it has a certain effect with a certain loop. So if I change the concentration of x, like here x is 0.72, x is 0.72, x here is changed to become 2.4. Is it going to make any effect on the rate of the reaction or no? In order to know that, we have two reactants, so I cannot change both of them at the same time. I have to keep one of them aside. So I have to keep the y aside. Otherwise, if the y is changed and x is changed and the rate of change, I will not know if the change in the rate is due to changing y or due to changing x. So I have to make one of them fixed. If I fixed the y, so pick up 2 two experiments in which the concentration Y is never changed. Pick up two experiments, 1 or 2 or 3, in which the concentration of Y is not changed. Why? Because when you do that, when you pick up that, this means that the changes that will happen will be in X, and you know the effect of changing X only. So I will pick 1 and 2, because in 1 and 2, as you see, the concentrations here has not changed of Y, it's fixed. Only the concentration of X has changed, it become from 0.72 into 0.24. So I pick one experiment, 1 and 2, because I know that in experiment 1 and 2, the rate of reaction will change depending only on the change in X, not in Y. So I can put Y aside so it doesn't confuse me. The rate of the reaction changes. How does it change? It changes from 4.2 multiplied 10 to the power of minus 3 into 4.7 multiplied 10 to the power of minus 4. And here changes from 0.72, the concentration of X, into X becomes 0.24. So let's see what happened here. Let's get our rule before we see our answer. Our rule tells us that how we can find the order of the reaction relative to any reactant. If the change in concentration of a certain reactant does not cause any change. So yes, it's changed, but what happens in the rate of the reaction, if it makes no change, then I'm gonna say that I am a change of zero order. Zero order means it made no effect, no change on rate of the reaction. This is my first option. So I will not write one so it doesn't confuse you. This is my first option. My second option is that when I changed the concentration of the reactant this time, the same change happened to the rate. So same change happened to the rate. What does it mean, same change? It means if you multiplied the concentration by 2, the rate of the reaction will be multiplied by 2. If the concentration is multiplied by 3, the rate of the reaction is multiplied by 3. If the concentration is divided by 2, the rate of the reaction is divided by 2. So whatever you are doing to the concentration is happening the same to the rate of the change. If you divided the concentration by 2, the rate is also divided by 2. In this case, you say that the reaction is from the first order relative to this reactant. First order relative to this reactant. So when you will write this reactant in your rate law, you will put it to the power of 1. To the power of 1. So you'll say, for example, A, and you will put it to the power of 1. But here, do you remember the rate law? When we say rate is equal to K and then A will be to the power of 1. What about if it is zero order? Then you will put it as a power of 0. Particularly, let's say this is reactant P, and when you check the change in concentration, does not make no change on the rate of reaction. So this means it is zero order. So it is B to the power of 0. If you have anything to the power of 0, it's equal to 1. What does it mean 1? Means it doesn't appear here. Means it's not there. It means you don't write P at all. You don't write P at all because it's to the power of 0. But when you write it is to the power of 2, when you write that it is to the power of 2 or second order reaction. The second order happens when the change in concentration causes a change which is to the power of 2, a double change, which means that if you change the concentration multiplied by 2, the rate of the reaction does not change like in 0 and does not change in the same way, in the same equivalent way here, like the concentration here multiplied by 2, here multiplied by 2, here multiplied by 3, here multiplied by 3, here divided by 2, divided by 2, but it changes in a way that is concentration is multiplied by 2 to the power of 2. What if it is concentration multiplied by 3? Then again, 3 to the power of 2. So it's multiplied by 9. What if the concentration is divided by 2? Then the concentration is divided by 2 to the power of 2, which is divided by 4. What if it is concentration is divided by 3? So it is divided by 3 to the power of 3. And that's what we will find in our example here, as we will find that the example here. When you divide it by 3, so this one is divided by 3 from 0.62 to 0.24. Here also is divided, but when you calculate 4.2 multiplied by 10 to the power of 3 divided by 4.7, you will find that it is divided by 9. So the change is power to 2. Change here is divided by 3. Here divided by 3 to the power of 2 is equal to 9. So it is change of the second order, change of the second order. That's why I will say y x is to the power of 2, so it's from the first order. So you will write this equation. This is K concentration of x to the power of 2. And when you fix y, I will fix y. How do you fix y? You look in two experiments in which x is fixed. That's 1 and 2. I don't see any change in between x here, 1 and 2, but I see that y has changed. So experiment 1 and 2, x is fixed and y is changed. But did you notice anything? When you changed y from 0.16 to 0.30, the rate of the reaction didn't change. And you said when the concentration changes and there is no change in the rate, it will be zero order. What does it mean, zero order? It means that y will be to the power of 0, because when you change it y, there is no effect on the rate. That's why we'll say y to the power of 0. That's why we'll not mention y. So our reaction will be like that. X rate rho is equal to k multiplied x to the power of 2, and that's it. This is our rate law. What is the overall order? That's very easy. It's irrelevant number. All you have to do is add these two numbers together. So add all the orders together. It's 2 plus 0, so it's of the second order. Can it be more than that, like 2 plus 1 equal to 3 or 4 or 5? Whatever number you get by addition is your answer.